Welcome to Maths with SAS, your go-to channel for mastering mathematics step by step. In this lesson, we will explore Chapter 1, Working with Numbers, as part of the Grade 7 Mathematics series. In this chapter, you will learn about positive indices, multiplying and dividing indices, zero indices, negative indices, and standard form. We will break each concept down with clear explanations, examples, and practice exercises. At the end of the lesson, we will provide a cheat sheet summarizing all the key rules, so stay tuned and make sure to watch until the end. Let's get started. An index or exponent tells us how many times a number is multiplied by itself. In the expression 7 squared, the large number, 7, is called the base, and the small number, 2, is the exponent or index. This means we multiply 7 by itself, giving us 7 times 7, which equals 49. Exponents help us write repeated multiplication in a shorter and more efficient way. A positive exponent means we repeatedly multiply the base by itself. Here's an example. 2 raised to the power of 3, or 2 cubed, means 2 times 2 times 2. The result is 8. Try this. What is 4 cubed? Write your answer in the comments. The general formula for indices is a raised to the power of m equals a multiplied by itself m times. For example, 3 raised to the power of 4 is 3 multiplied by itself 4 times. This formula works for any positive integer exponent. So remember that a positive exponent means repeated multiplication. When multiplying numbers that have the same base, we do not multiply the numbers directly. Instead, we add the exponents. For example, let's take 3 squared multiplied by 3 to the power of 4. Since both numbers have the same base, which is 3, we add the exponents. 2 plus 4 equals 6. So, the answer is 3 to the power of 6. The general rule for multiplying indices is that when we multiply two numbers with the same base, we add their exponents. This is written as a to the power of m multiplied by a to the power of n equals a to the power of m plus n. This rule makes calculations easier by reducing repeated multiplication into simple addition. When dividing numbers that have the same base, we subtract the exponents instead of adding them. For example, let's take 7 raised to the power of 6 divided by 7 squared. Since the base is the same, we subtract the exponents. 6 minus 2 equals 4. So, the result is 7 to the power of 4. The general rule for dividing indices states that when we divide two numbers with the same base, we subtract their exponents. This is written as a to the power of m divided by a to the power of n equals a to the power of m minus n. This rule is useful when simplifying expressions with exponents. A negative exponent means that we take the reciprocal of the number with a positive exponent. For example, 2 raised to the power of negative 3 can be rewritten as 1 divided by 2 to the power of 3. Since 2 to the power of 3 is equal to 8, the final result is 1 over 8. Negative indices help us express small values efficiently. The rule for negative indices states that a to the power of negative m is equal to 1 divided by a to the power of m. A negative exponent moves the number to the denominator. Any number raised to the power of 0 is always equal to 1, as long as the base is not 0. For example, 5 raised to the power of 0 equals 1. Similarly, 100 to the power of 0 is also 1. This is because any number divided by itself is always 1, and that is the pattern that follows when applying index laws. Zero indices follow the rule that a to the power of 0 equals 1, as long as it is not 0. This means that even a large number, such as 1 million, when raised to the power of 0, is still equal to 1. 0 to the power of 0 is a special case in mathematics. In some contexts, it is considered undefined, while in others, it is taken as one in specific mathematical situations. For most of our calculations, we will treat 0 to the power of 0 as undefined. Let's discuss this in another video in detail. Let's discuss the topic of standard form, also known as scientific notation. This method is used to write very large or very small numbers in a simpler way. Imagine you are dealing with a number like 4,500,000. That is a big number, and writing all those zeros can be tiring. Similarly, a very tiny number like 0.000005 has too many decimal places, which can be confusing. To make things easier, we use standard form. Standard form allows us to express numbers using powers of 10. The general rule is a into 10 to the power n, where a is a number between 1 and 10. N tells us how many times the decimal point is moved. Let's look at converting large numbers into standard form. Let's take 4,500 as an example. Find the first non-zero digit, which is 4. Place a decimal after it. This gives us 4.5. Count how many places we move the decimal to get from 4.5 back to 4,500. We moved it 3 places to the left. Write it in standard form. For 0.5 times 10 to the power 3. The power of 3 means the decimal moved 3 places to the right to get back to 4,500. Let's look at converting small numbers into standard form. Now, let's take a small number like 0.005. Find the first non-zero digit, which is 5. Place a decimal after it, giving us 5.0. Count how many places we move the decimal to get from 5.0 back to 0.005. We moved it 3 places to the right. Write it in standard form. 5 times 10 to the power minus 3. The negative power means the decimal moved 3 places to the left to get the small number. In standard form, a number is written as a multiplied by 10 to the power of n, whereas between 1 and 10. Move the decimal point until you have a number between 1 and 10, then count the places moved. Now, let's test your knowledge. Try solving these questions and write your answers in the comments. Let's see who gets them all correct. Here is a quick summary of what we learned today. Multiplication rule, add the exponents. Division rule, subtract the exponents. Negative indices, move to the denominator. Zero index, always equals 1. Standard form, convert numbers into the form of multiplied by 10 to the power of n. You can download this cheat sheet from description section. That's all for today's lesson on working with numbers. If you found this helpful, don't forget to like, share, and subscribe for more engaging math lessons. See you in the next video.